had a really hectic day at work. There's like everything broke, and so I'm sorry if I'm like a little scrambled today. We'll do our best. I feel more like all of you students must feel like when you're seeing all this new wacky JavaScript stuff. so so it's not ideal, but yep. Okay, we're live on YouTube. We got the captions. I think we're all ready to go, and it's just about 5:30. I'm gonna refill my water cup, and I will be right back. I'm at work, by the way. This is our office in Syracuse. It's needs a little love since the whole Corona thing. We haven't really come back and put everything back to where it was yet. So anyway. Okay. So let me get all my stuff. Oh, so the first thing we'll do, like just about every class, I'll share my screen. And there's a new folder in the GitHub repository. So just like before, go to GitHub Desktop, make sure you're in the Careers in Code Classroom code base. You got the book here. Current branch should be mastered. This might say pull if you haven't got the latest, but just click it until it says fetch. If you've got changes over here, control click discard. Once you are on this screen, you're all up to date. You do open in Visual Studio Code. And we should see this new folder here. It won't have this part in your computer, but it should have these 4 files in it. It's week 7, day 1, card trick. And that's really an example that might go 2 days. So we might be doing part of it today, part of it tomorrow, depending on what we have time for. But first, I really just wanted to go through the weekend assignment and do a demonstration of how you'd solve that, just because I think you can see how it's different from what you might have done. And a lot of it is, again, it's just kind of how I would go about it. So it might be good to see that process. So if you would like to follow along, we're probably going to, I think I'm just going to discard my changes at the end of this, but I can paste them in Slack. So don't worry about, if you want to type to follow along, just be ready to go and discard your changes later and grab them from Slack, put them in another file if you need to. So I'm going to work right in the assignment 23.js. We're in Cohort 2, Module 4, W6 weekend, assignment 23. And I'm going to get my terminal ready. So I will control click on W6 weekend and do open an integrated terminal. Please speak up if you're having any trouble with any of this. I'm kind of still going over the steps just because I think it's good to reiterate and get them. But yeah, we want to make sure you're able to follow. Carolyn, you're having problems in your GitHub desktop. Yeah, sure. Go ahead and share. I will stop sharing.
The only problem is I have to screen share on the Mac.
Okay.
And now I'm gonna have to jump in a little bit because I can't. I got to find the window that had that in it. That's where I have the.
Okay.
Sorry.
We can do a breakout room for this to get you back, because all we're doing is going over the weekend assignment, and this will be on YouTube later. So
yeah.
you want Karen, would you be able to try to get back to the code base, classroom code base, and opened in Visual Studio? We're not going to really make any permanent changes. Uh, and this is really just a demonstration of the weekend assignment. So I think it's okay to come back, by the time I'll ping you when we're.
Yeah, because I need to have that, but if you don't mind waiting to get the assignment, then I'm okay. Now I can't even find how to share screen on the Mac, so
Okay.
Anyway, I'm mute, sorry. I'm mute.
Karen, what should we do? Should we do a breakout room?
Yeah, I can go into a breakout room with her,
Okay.
so that we could get her the code.
Okay, and I'll do the weekend assignment breakdown. I'll let you know when we're moving to the next thing.
Okay.
All right. I don't know how to. Oh, breakout rooms. Okay. I'm going to get into the weekend assignment. Yeah, and it's fine to watch this later. This is really just my process for going about solving it. And if you want to ask about your submission, I mean, I know most people have already submitted, and I'm going to send feedback on those. But if you want to ask more about your particular approach, it's fine to absolutely schedule one-on-one time, because then I can go into, but this is going to be mostly just a demonstration of this. And you might already have done something largely the same. But here we have our program, and this assignment is really kind of your first exposure to something called refactoring. This is normally like a large amount of time that you spend as a programmer. If you want to make your programs high quality, easy to work in, easy to understand, you're going to end up spending actually quite a bit of time doing this kind of thing, where you're basically reorganizing your code and making it more easier to understand, more suitable for what you're trying to achieve. And this is a very kind of like straightforward type of refactoring. It's very clear that we have, a lot of duplication here that we can sort of get rid of. Sometimes it's not so obvious, whether something should be refactored or how it should be refactored. And even in this example, there's several ways to go about it. But the basic thing we want to change is that we have our symbols for 6 dice faces. We're saving we have some variables that we're going to use to store the total of a roll of our current dice roll. So we're going to roll these 5 dice at a time. We're going to store how much their total adds up to. We're going to keep track of the best roll we have so far. And then these are arrays basically to allow us to store, accumulate these random rolls, and then print out the corresponding dice so that we can show to the screen what dice were rolled on each roll. Now this here is a little redundant, because see, these are assigning 0 and empty array to some variables that we already assigned 0 and empty array. So these don't do anything right here. You could comment them out and it would work exactly the same. The reason I left them in there is kind of as a clue that if you take the code from line 20 here all the way down to 46 and you remove all the comments are describing what it's doing. It's basically the exact same code as 50 to 64 and 68 to 82. The only difference is that we say third roll, second roll here, and first roll here. So we should be able to write most of this code only once and then reuse it 3 times, one possibility for doing that is to not to use a function at all. We could do this with just a for loop. We could say for let I equals 0, I less than 3, I plus plus, or I equals I plus 1. And take all of this code, Command X, cut it, paste it up into this for loop. Now, in order to keep it easy to understand, I need to fix the indentation level. So I need to highlight line 46, the end, all the way up, everything inside the for loop. And actually up to this line's okay. Actually, these two, wait a minute. Hold on a second. What did I do wrong here? This ends right here. That doesn't seem right. Let me undo a couple times. Command Z, Z, Z. Oh, wait a minute. Maybe I was looking at my inner for loop. Okay, copy everything here. Or cut, Command X. What is, hold on. I'm sorry. I'm messing up today. I don't know what I'm doing anymore. Undo, undo, undo. Okay, for loop. That's all we've done. For here, copy from here to the first time it's logged, or cut, sorry, Command X. Inside here, Command V. Okay, here's what I got wrong. So we need to highlight from, see how this one is indented, and we really want everything inside this for loop to be bumped over a little bit, to get a little bit of indent, so that we can see that it's inside a loop at a glance. We can see that there is some pair of curly braces that contains all of this that I highlighted. So you can do that by highlighting all the lines and pressing the tab key. It will scoot all of the lines over. So now you can follow this line, trace this little gray line, if you can see that, from the top of the for loop all the way down. It should be clear all the way to the end of the for loop. And then everything should be shifted over so that it sort of starts one tab or 2 spaces in, or 4 spaces in. This is in the slides, but nobody really agrees on whether it should be 2 spaces per tab or 4 spaces or an actual tab character. There's all these different opinions, and this has been something programmers have thought about for forever, I guess. So I do 2 spaces in here. It gives you more room when you indent. It gives you more room for your lines. As long as you can follow, and the more important thing really is that the structure is consistent so that you don't get confused. And this is something I'm going to start doing on the feedback for all the homework. Some people have more and less trouble with this, but making it so that every line is indented correctly is one of those skills that it's pretty good to practice as a programmer. It's a very simple thing, but putting care into this will make your code look better to everybody. It will make your colleagues happier to work with you. It will make you happier when you go back to your old code later and you're trying to figure out what the structure is. And it is very much worth it. This is one of those things I do not compromise on at all in my job. I will not leave something with the wrong indentation. Now, sometimes it's not totally clear whether you should, put this like this. Some people prefer to put the end thing here. Some people prefer to, I don't think anyone does it like that, because that's just I think JavaScript will just error on that. But sometimes it's not totally clear if you're not working with a very strict style guide, how some cases of indentation should work. But if you know anything is wrong, if you can see like this is shifted back and it really should be scooted in, it's very important to, as you go, to make sure that your indentation is in the right place, because these kinds of little differences will add up over time, and eventually you won't be able to look at your program and really understand it. Now there's a tool that can help us with this, and if you want to see that today, we can look at that today, but I think I'll probably do it later this week, or Max will do it next week. It's called ESLint, and it should be able to fix things like indentation for you. So if you'd prefer not to do it manually, you can rely on a tool for this. I think it's good to get in the habit, though, of recognizing and tidying up code when you can, though. So that's speech over. We've put the first set of our roll the dice, roll the 5 dice, add the total together, check if our best total, if this current roll is better than our best total, save it as our new best total. And then turn our dice indexes, the positions in this list where the dice are that we are quote unquote rolling, turn those into the actual characters that display the dice. And then finally, print out the result of all those dice. We have chat going on. Let's see. Oh, breakout room. Let me know if I need to stop, Karen, or anybody. Please speak up, but I'm going to keep going. So here's the thing. Now that we've done this and put this in a loop, we still might want to print our best total at the very end, but everything else we can delete. And this is like a feeling that you should learn to really like, when you get to delete a bunch of code and your program still works. It still does what you need it to do, but you've deleted a bunch of code. That's the best thing you can possibly do as a programmer. There's a story, a famous story where I forget what company it was. It might have been Microsoft in the 90s. There was a manager there, and they told everybody, we're going to put a system in place where we track how much code you're writing. And we want productive employees. We want productive programmers. So you're supposed to try to write some code and log, this, you're going to basically get calculate how much code you've added to our code base. And then that's like it's good to be contributing more code because you're productive. One of the programmers, somebody, one of the kind of my original Microsoft like wizards who was good at programming was working on a program, and they found that basically by refactoring, by kind of doing what we're doing here, they were able to replace a huge amount of code, like a huge amount of unnecessary extra code, with a much simpler, more elegant version of it. And the famous, like the punchline is basically they turned in their report for how much code they had written that week, and it said negative 20,000 lines of code, or negative 2,000 lines of code. And like the point of the story is like, that is the best thing you could possibly do as a programmer. Pretty much, it's there. If you are removing code and you're not breaking anything, you are incredibly improving the program, almost by necessity, because what you've done is you've simplified the whole thing. You've made it easier to work with. You've possibly made it even faster to run on the computer, and all of those things are good. So I guess what I'm saying is you should feel really good if you ever get the opportunity to delete a bunch of code like this and say, nothing really changes. But now we have less code. Code is sort of a liability. It's not like something you just want to keep adding to. You want to keep it organized. You want to keep it clean. That's almost more important than writing it in the first place. Once you get into, doing this on a daily basis in a job. Anyway, so I have my terminal here. We can run this just to make sure we still get 3 dice rolls and we still get a best roll, even though we've removed a large amount of our code. So I'll run this by doing node w6 weekend. Cannot find module. Oh, whoops. It's not called that. It's called, no. It's called node. It's node assignment. And I can tab, nope. Yep. I can tab complete to make sure that file really does exist. It's called assignment23.js. So run this. And hey, it looks like it works. And if you look really carefully at the dice, it does add up. That's 12, 16, 21. That's 21. One problem is, though, they all say the first roll now. And that's because that was really the only part of our code which was different from the first to the second to the third. Ariel, would there be an extension for tabbing? You mean the .js extension?
No, so when you go, like you're doing Node and you're typing it in a terminal,
Yeah.
you know how you hit tab? Mine doesn't do that. For like 90% of things I could hit tab for that you guys do, mine doesn't do it. So I don't know if I'm missing an extension. I have to type it out every time.
No, that probably
I had the same issue.
Does it actually work though?
It never
To type
tabs.
it out?
No. If you type it out, does it run or do you get an error?
No, it runs. I was just looking to save time. You guys like can tab and it'll come up, and mine doesn't do that at all.
So you're in this console, you type node space A and hit the tab character and you get nothing?
Yeah. It's done that since the beginning.
Huh.
I didn't know if there was just like if it was an extension I needed or
Nope, you shouldn't. I'm sorry about that. You have to do more typing, I guess. And careful typing. But if it runs, that's okay for now. How about let's do this in office hours, or set up some time. Just ping me on Slack if you ever want to look into this and try to fix it. I have no idea really why it wouldn't work, especially if you can run the file. So the file definitely exists and you're definitely in the right folder that you're trying to run it from, and it all works. It just doesn't autocomplete. I'm not sure. Does this say ZSH or bash up here?
for mine it's ZSH.
Okay.
It's always done it. It wasn't a big deal. I mean, I have no problem typing it out. It still runs. I just wasn't sure if there was like an extension I missed that you knew off the top of your head.
There's nothing you should have to do. It should work. I don't know why it doesn't. So.
I'm not too concerned. That's okay. Thanks.
Yeah. Okay, so yeah, we're printing out first roll 3 times. That's the only problem. Otherwise, this worked great. We got it into a for loop and we don't have any duplication. Now, the assignment though said specifically move some code into functions. So like this is not necessarily, this is a way to avoid the duplication. That's fine, but it would still be nice to move some of this into functions. The first thing we can do, and we'll fix this role thing later. I'll just say a role for right now, and we'll fix that later. So we get 3 A roles, and the best total is this time 19. Okay. here's what we might want to do. Let's try to figure out a way to, and if you don't mind, the comments in the original assignment are very extensive. They're just everywhere. And I think they're a little too much. Like, we don't have to worry so much about how everything really is working. You can go look at the original file if you want to see some of these comments. They're just trying to explain some of the code here. But let's make this a little more compact by deleting our comments for right now. And we can see a couple of like pieces that we might be able to break apart. The first thing we could do, we could change this into a function, just very, very simply by saying function roll dice, and then get rid of everything in here because it only makes sense for a for loop. So now, instead of this block being a loop that always runs 3 times as soon as the program runs, this is now a function we can call 3 times. There's a problem with this. If we try to run it right away, it never runs. Nothing is calling this roll dice function. So it never runs any of this code, not even once. We still need something to run this function 3 times. So we can put our same for loop now down here, our old for loop. For, we'll type it out again. Let I equals 0, I is less than 3. I'm going to start using I++ now. I think everybody's more used to it. And I can call inside this function, roll the dice 3 times. Roll dice. We'll call our function to run it 3 times. And now we're back to the same behavior we had with just the for loop. This is arguably better though, because we've separated the logic, we've sort of cleanly separated the part of our program that does something 3 times from this other part which just rolls the dice once. Now we can kind of mix and match. If we wanted to roll the dice and then print, or sorry, not print, console. I'm thinking of Python. All right, take a break and then do it again. Roll the dice 3 more times. This now, it's much easier to look at this and understand the structure once things start getting more complicated. Do some other stuff. So let's say there's, you roll the dice sometimes, you took a break, do some other stuff in the middle here, and then you keep rolling the dice 3 more times. It's a lot easier to look at this and understand. And also, there would really be no way to break this up into 2 sets of 3 if we didn't have this function. Because you'd need a copy of whatever's in the top for loop, all of this stuff up here, you'd need to copy that into the bottom one. So as soon as you move away from just looping once, the function is actually going to be a better way to organize it than just putting it in one loop. That's not as, it's not as durable or useful or flexible, I guess, as putting the behavior into a function. So, if we did this, we'd get 3 rolls, take a break, do some other stuff, 3 more rolls, and print out the best total of all 6 rolls, I believe, because, because of what we'll talk about in a little bit, but we've already seen a little bit about scope. The place we're storing our variable called best total is outside our function, outside our loops. It's in a global, it's in a scope that is, oh no. Oh, my computer's running out of batteries. Hang on. Oh, boy, this is that the best total is the same reference from all the way up here. And every time we assign to best total here on line 32, we are really looking outside of our function and finding something in the scope outside of our function and altering that. And that is the same variable every time we run the loop. So all 6 runs will be touching the same best total variable, even though it's outside of our function. This isn't always a good thing because this is a side effect of our function. And in fact, when we assign to current total, that's another side effect of our function because current total is also out here. So if you had 2 different functions that both altered current total for different purposes, they both had some concept of a current total, but it was for different purposes. If they're both touching the same thing outside of all of those functions, then they could interfere with each other and have surprising results. For current total, the solution is pretty easy. Because we're inside a function now, we have a whole new function scope for any of our variables. We have anything we define with let or const or even the var keyword, the var keyword, which we don't use in really any of our examples. If you define a new variable here, let current total equals 0, even if, let's say, this was a const out here, the program is fine. These are now different. We've defined a new variable called current total because we've put that keyword there. And we're no longer assigning or trying to assign to this. We have a totally different concept of current total, which is only relevant inside this function. If we tried to log current total after the function, well, it would still work because of this one, but we can delete this one now. So we can get rid of that. We can actually do the same thing with all of this because you notice it's the same pattern. We're only using these variables inside our function. And yeah, we're not doing anything with rolled dice indices or rolled dice symbols. So we can just move this defining these variables into here. This one is redundant, but we end up saying at the start of our function, we have 3 new variables we are defining, which are scoped locally. Yes, they're scoped locally to our function. And they are no longer visible outside. So let's simplify this. Let's go back to just having 3 loops. But if we try to do console.log current total out here, it no longer exists in this scope. Best total still exists because we do need to persist that best total from one run to the next. But current total no longer exists. If we try to run this, we're going to get an error saying current total is not defined. Well, that's because in this scope, it has never been defined. It's only been defined in an inner function scope. And the rules of JavaScript scoping, variable scope, this is in our slides today. The rules of JavaScript scoping say you can always look out. So anything, this random index can only be seen inside this for loop. This can be seen inside the for loop too, because anything in here can look out a level. And again, best total, that's all the way out here. So this is inside an if statement, inside a function, and the real variable's all the way out here. But JavaScript, you can look outside the current scope to find a variable. You can never look inside. You can't look into this function from out here and see current total, because you can't look into any scope that you're not inside. You can only look out. And if there is a const current total equals not even a number, something else weird out here that's also happens to be called current total, this one's going to win. So as long as there is a current total, another one defined in this scope, this one wins. If there's nothing defined in this scope, then it goes to the next outer scope and says, well, is there something defined in here? And then so on until it gets all the way to the global scope. And if there's nothing defined in the global scope, as far as it can look out, then it errors and it says it's not defined. This scope stuff is rather confusing and will take some time to get used to, but basically this is one reason to put as much as you can into your functions rather than outside of your functions. And the same thing, with your for loops. If you need something outside of your for loop or outside of your function, then that's one thing. But if you can put the thing inside your function, that means that it's the places where it can affect your program are smaller. Your function is contained to, your variable is sort of contained inside the most inner scope where you define it. And then, you can look out if you need to see stuff with more scope, but you can't look in and accidentally grab something that's inside your function from outside it. You can't do that. Yes, Carolyn, there is Shift Tab, which does backwards. Shift Tab is backwards, Tab is forwards like that.
So for both forwards and backwards, it will keep the relational, if you will, indentation that you have, like if you use it. So if things are indented a little bit, they'll stay, right? Because
So
I really can use that when I'm writing this stuff, and I wasn't sure. So Shift Tab, okay.
Yep.
And that's
highlighting and doing Tab and Shift Tab. This, see, the four will stay grouped together. So I do Shift Tab, these stay in a little bit. Tab, 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 Shift Tab. Now, if I do it too much and these top and bottom ones can no longer move, then they all smush together. So
it's a train wreck.
Yeah, watch out.
So Shift, is that just on the Mac or is that on a PC too?
I think it's the same on both.
Okay.
Yeah.
I can experiment. Most of my coding I'm doing on the Mac anyway, so at this point. All right, thank you. And I'm out of the room, obviously. She let me out of my room.
Okay. Did you get any luck with the setup of your repo, or are you going to try that later?
Yeah, I still don't understand what was happening, but one of the theories we have is I may have multiple windows of the same app open. And my command bar at the bottom is set up in such a way you can't really tell that.
Okay.
And that would, if there's like two desktops going, but we have to, I'm still not sure because I kept doing all the stuff she was showing me in the past and we'll go back to this other thing. So we're going to see, but I did get everything pulled. So I'm good for now. Thank you.
Cool. All right.
Yeah. One less thing.
Okay. So the scope stuff, this is going to be confusing for a while because this is really the first time we're talking about it in depth. It's part of our slides today. But just kind of understand that, if you're not using the current total out here at all, and you're only using it inside the function, it's much better to define it inside the function too, because this keeps it's like hygiene. It keeps your code cleaner. It keeps things in one function from interfering with things in another function. Now, we'll get back to this one because this function still alters. It still reaches outside of its scope and alters this global best total variable. And there's a way to do that, to do what we want to do and clean this up a little. But first I just want to show like another example of another function you could pull out, and that would be just this part. So this is that kind of confusing random math that we did to grab ourselves an index of one of these dice at random. So remember, this is index 0. This is at index 1, 2, 3, 4, 5. So we really want a random integer from 0 to 5. One of those numbers, 0, 1, 2, 3, 4, or 5 at random. And this is how you do that in JavaScript. It's a little tricky. But now that we have this here, we could put a comment that says, select a random integer from 0 to 5. Sure. We could mark this with a comment, but then as you saw before, like so many comments, everything gets really large and you have to scroll around, and scrolling is no fun either. So we could grab this stuff here. We know what this is doing. We might as well just make this its own function and give it a name so that when we see it here, we don't have to wonder what's going on with that math floor thing. We know, we can understand our intent by running all of that code that I just cut out of there. So I remove that from here. I'm going to make a new function called get random die index. And all it's going to do is return the part we just cut out of there. And now what I can do is, instead of all this stuff being just inline here, I can run our function called get random die index, and then we don't really have to worry about it in this context. We're working in our function. Who cares how you get a random die index? We just know that that's what we're trying to do right here, and we can worry about how it's done if we want to work on this function. So as long as you have this function correct, you can just forget about the details, and it will make all of this stuff easier to understand. So we could actually just remove this from here entirely. Oh wait, no, let's not do that, because we need to use random index in 2 places. I was thinking, we could just put this into here and substitute it for the variable here. But since we're using it twice, I'm not going to do that. Okay. So let's see. I don't know if there's any other places where they're very obvious that we could break out a function, except maybe this one. So we could replace this. Let's pull this out. Let's make another function called get die symbols from die indices. And this will take an argument, which is an array of indices. And we're just going to return indices.map this. We'll take this part of our program out and give this a name too. So if you don't want to be looking at this map and being like, what is this doing? You can do the same kind of thing here. So rolled dice symbols could be the result of calling get die symbols from die indices and passing rolled dice indices. And then we could even do this. We can pull this part out. Function get message for die symbols. And we return this, symbols. And this becomes just symbols. And it's the same idea here. We console.log get message for die symbols, rolled dice symbols. And actually, all of this rolled dice stuff, the function itself is called roll dice. So these are all pretty much redundant now. Like, we can simplify our namings because we're in the context of something where our intent is to roll dice. Why do we need to keep repeating that everywhere. There is only one set of indices, one set of symbols while we have this intent to roll our dice. So we can simplify the names by basically removing rolled dice from everything. So indices dot push random index, that's good. Symbols, we'll just call this symbols. And this is indices. And this is symbols. So I think I got all of it. But now, we have it's less of a mouthful. This doesn't have to be current total also, because there is no, it's all in the context of this roll. So there's no current, it's only the one total. So we can rename this total. Total. And now we still have best total. That's still out here. That's still all the way from out here. But we'll figure that out, what to do about that right after. Let's just make sure that everything still works, though. So we're rolling dice 3 times. This goes away because that was just a demonstration that total thing doesn't exist outside of our function. So it still works. We have our 3 rolls, best total 27. So let's just do 2 more things. Let's see, get random die index, get die symbols from die indices, get message for die symbols. Yeah, these 2 are maybe a little too broken apart, because we have like one function to convert into symbols, and a second to just print the symbols. And we're not using these for anything else. We're just getting our symbols and then printing our symbols. So you could argue that, no, these should really be one function. And let's do that anyway, because I think it's good to just get, whether or not that's the right way, we don't know. Who knows? You could argue for either one. But it's cool to kind of get practice reorganizing functions, doing this kind of refactoring. So instead of this being 2 steps, I'm just going to say get message for die indices. So this will go straight from our indices to our message. And instead of returning this first thing, we'll say const symbols equals indices dot map this part where we convert indices to symbols, and then we'll return the second part. And we return, it's still called symbols now because we defined the same thing here. Now we can delete this function. Why not? And down here, these are no longer relevant. So it's now called get message for die indices. And we just log that. And now this thing is not even used. And now symbols, it's turned dim here because we're not using it anywhere inside our function. So we have this now to just convert our list of the indexes of our random dice right into the message, because that's the only thing we're doing with it. Semicolon. And everything should still work the same. Okay, last couple things. The first is that we can pass a second argument here to say roll number. And we could have this print out roll the same little interpolation thing, so $sign and the curly brace, and roll number. So if we pass the second argument with a number in it, we can make this, print a slightly different thing. We could say print roll 1, 2, 3 fairly easily. And that's because, actually, no, we couldn't. we have to pass that roll number all the way from here. So we need a roll number here too. And we need to pass that right through to here. And then all the way out here where we call roll dice, we need to give it our number. So this will be, let's say I plus 1. So it'll say 1, 2, and then 3. Because I starts at 0, goes 0, 1, and 2. We pass 1, 2, and then 3 into here. We only use this here to print our roll number here. But we won't get a roll. We'll get roll 1, roll 2, roll 3. And that's a little annoying because now you have to manage this variable all the way through. So there's a bit of a trade-off here. By breaking this into functions, we made the part of our loop that says, well, the number of the loop that we're going through has to be passed all the way from here to here, and then into here as this, and then from here used to actually print it. So we kind of now have a bunch of management of our function arguments to do rather than a more complicated program. But it should work. We'll get roll 1, roll 2, roll 3, and we'll still get our best. The last thing that I would do in this, and then obviously this is never going to be done. Like tonight, I'll be like, man, we could have fixed it a little nicer by moving this over here. And that kind of thing, you'll just never be done tweaking your program if you really are like, there's so many things about this. Like the word indices just sounds gross. Is there some way we could use a better word? Dice versus die. So this is roll dice. This one is die. Why not? This one should be dice. I don't know. This stuff will, this one's singular. So this one should definitely be die, but that's an ambiguous word. It also means to pass away. So, you're going to constantly be questioning, is this really the best organization of your program? That feeling is just normal. And, too bad. It's just how it is. You're never going to find the perfect way to do anything but a trivial program. So, I think it's definitely good to be in the habit of cleaning up your program and trying to figure out a nice way to break things out so that when you look at your program, you can get the best understanding of it possible. But you're never going to get a perfect layout of a real program. You just have to go for the best one you can do. And that's just part of the craft. So the last thing we can do that I think we really should do, and then I'm going to say it's good enough, we're not going to mess with it anymore, is to make it so that our function doesn't reach out and mess with this global variable here, because I don't like leaving that there. That's something that's it's a risky thing to leave sitting in a global scope. If your program grows bigger and there's another concept of best somewhere, it could interfere. They could interfere with each other. So we really need to figure out some way to kind of return the same or have this same thing achieve the same thing without having to assign to a global variable in the middle of our function here. So what I'm going to do is, why don't we just pass in best total as our first argument? And then why don't we have this part here? Well, first of all, let's put our console.log up here so that we still get a nice printout. And this is still a side effect. Our function still has a side effect, but we really just want to show, we just want to show our progress. We want to show that there's a roll happening. It's probably okay to leave a side effect here. But for the end of this, we have total, and we were passed a best total in to our function. Why don't we, instead of assigning to this global variable, let's just get rid of this. And let's say if our total is greater than our best total, why don't we return our total? Because we can return something from this roll dice function too. And if it's not, let's just return the best total. So if our best total is 0, any total greater than 0 is going to hit this code and it will return our new total. But if our best total is the same or better than the total after that we started here and made out of all of this code, if our best total is still greater, then this will be false and we'll return our best total. So what we can do here is still have to store that best total somewhere that persists. So we can't do let best total is 0 inside of our for loop. We still really do, in this case, need some bit of global scope. We need it to survive every loop of the for loop. But at least we can move the behavior that changes it from inside of our function to inside of the for loop that's right next to it. And we'll pass it in as our function expects as the first argument. And then we'll say best total equals the thing that we return from our function. So this is going probably way beyond what most of you submitted as your weekend assignment. This is like totally tearing the program apart, rethinking it, second guessing that, rethinking it again. So I don't want to say like you should have done anything even closely resembling this. This is just a demonstration of what my process would be if I were given the same problem, all of the different things I would be thinking about, and how they kind of relate to some of the concepts we were trying to learn. And the basics are using functions to replace tricky bits of logic, like this bit or this, that are not obvious what they're doing when you're looking at them. Instead of adding a comment and making it even more stuff to read, replacing those confusing bits with the function down here, with just the call to the function, which makes clear your intent and also hides the complexity of what it's really doing so that you don't have to think about it in the context of this function itself. You can continue working on what this function needs to worry about and not worry so much about how you get a random die index. You can just say, at this point, we should get a random die index. And that's all you need to really think about in this context. And that is really the most basic power of functions in JavaScript. So that's one takeaway. And the other takeaway is really just that there are so many little ways you can think of to try to improve your program that, you're never going to be like totally get to a place where you said, this is it. You can't improve it anymore. You're always going to maybe be able to improve a program that you look at. So, to I guess not worry so much about perfect, think more about just what is a way to improve? What is a way to make it a little better? And do I really need to make it a little better? You could have stopped, right when we had the for loop, and you would have gotten rid of most of the duplication of the code without even making a function at all. And then you could have stopped without breaking out these little functions. You could have stopped. The function surely can just affect a global variable. You could have left the best total stuff as it was. That's, all of those things are just choices that we're making to try to make it a little bit better. And all of that is kind of up to you when you're working on your code. Oh, and the last thing is just the scope thing. That once we have things inside here, they're not visible outside. But no matter how many function here, if statement here, no matter how far in you are inside a set of nested curly braces, you can always look outside to see a variable that's in the scope outside where you are now. And finally, that a name that you redefine here is going to override anything in the containing scope. So in the most inner scope, it will first look for the name you're trying to use, right here, example. If it can find it in the same scope, it will use this one. And this is different than this. And this will actually even error because it's a const and it's trying to add to it. But it will use the closest one inside its own scope first, then it will look to the scope right outside it, then it will look outside that, and all the way, however deeply nested you are, until it gets all the way to the global scope. And if it can't find your name, your variable, anywhere in any of that, then it will error finally. So if we leave this in here, we have total defined in here, our total is going to be the last die that rolls, because this no longer means this. This now means this. And this is defined inside a for loop. So we've messed it up. Best total is 0. Wait. Yeah, oh, because we log the best total stuff is out here and we never even touch this variable, so it's still 0. We got to get rid of this so that we are referring to the right total. We want to look outside the scope of our for loop when we are keeping track of this total. Okay, that's a lot of concepts. I think I went a little overboard, but what are other questions and what should we pause to look at? And then we'll continue with some slides. Yeah. I'll paste this version into the pasted code, by the way. Yep. Yeah, me too. Today. Sorry. You know, I think there's like a lot here, a lot in this example. Let's, do you want to break early, or do you want to look at some of the scope stuff, the slides for that, and then break? I think let's look at some of the explanation for some scope concepts, and then break right after that.
Elena's got no preference.
Okay.
Tobias says slides.
All right, let's do some slides on scope. Okay. So like we stated, the variable all the way outside, the best total, the original place where it was in effectively global scope in the context of our program. Node actually has its own version of scope where each file, when you're running Node, each file, each module it's called, has its own also module scope. But for the purposes of our argument, the scope of that best total was global to our program because it was the only file that our program included. So global scope is the very top level. It can be seen by everything else in your program. Local scope is different because it can only be seen by whatever else is inside its same set of brackets, or inside another set of brackets, inside that set of brackets, but it has to be visible by looking out from the innermost brackets. You can't ever look from global into a function or from a function into an if statement or anything like that. Local scope means only its same scope or inner scopes can see whatever you've defined. It's local to the containing set of curly braces. And this is basically just reiterating what I said. You can access or change global variables from anywhere. And it's dangerous because you don't necessarily know what might be changing, what else might be changing your same variable. Yeah, this is what I'm saying. And then Node and React apps. Anytime your program starts to have more than one file, we haven't gotten to JavaScript programs that have more than one JS file, but anytime you are writing something that starts to have more than one file, each file normally can be considered its own scope too. So there really is not much global scope possible in most normal programs. But there is per file scope, which is when we're working in one file, it's the same thing. It's everything that you're working on can see that scope. We'll get to modules though, and multiple files in the same program later on. We're gonna start building React applications which have folders full of files, and you're breaking apart your code not only with functions and with code, control structures itself, but you're breaking your code up into many files in order to organize it even further. Just like you have, an HTML file that can link to another HTML file, you can have JavaScript code that sort of links or calls other JavaScript code in another file. And when you're doing that, the variables you define at the top level, as long as you use the let and const keywords or the var keyword, they are scoped effectively to the file that they're in. Every function creates a function scope. And everything inside, every variable that is defined, meaning let and const keyword or var keyword, every function that is actually defined inside that function is scoped to that function as well. And every other structure, like our if statements, a while loop, a for loop, a switch case even, those all create another kind of scope called a block scope. And it's the same rules apply. If you define your variable inside your block scope, inside your if statement, it is scoped to that block, to that if statement, basically. And this is where the let and const keywords are special, and this is why we prefer to use them partly, is because those are scoped to the block. If you use the var keyword, they are not scoped to the block, they are scoped to the next function. So basically, assume everything is block scoped, number one. So if statements, functions, while loops, for loops, they all have their own scope. And number two, the important other part is don't use var if you're doing that. Use let and use const, and then all of that, you don't have to worry about the difference between block scope and function scope. Just assume every bit of curly braces that has code inside of it, not object literal, but every time you have an if statement, every time you have a function, every time you have a while, a for, then you can understand the code inside of that, the variables defined inside of that to be scoped to that. And then this is the looking out. So any variables outside a given function or a block, they're still accessible as long as they're not in like the another block next to. So like if you had two while loops in a row, the variables inside one while loop are not going to be accessible to the variables inside the other while loop. I realize I'm pointing around, probably nobody can see my screen, but I'm trying to like illustrate this with my hands. This is, let's try to illustrate it with some code. So
Mal has a question, Gus.
yes.
He wants to know, should we always be thinking to keep variables and functions to local scope when writing code? He's just trying to figure out how much it matters if the program works.
So it matters once you go to change your program later or to add to your program later. It will matter in some cases, because the more closer to global your variables are, the more other code can possibly interfere with them. So what I would say is like, you always want, pretty much always want to, I'm pretty sure actually you always want to prefer to keep a variable in the smallest scope that it needs to be. And that's tricky sometimes, because like we saw here, we can't put best total inside our for loop because it would be redefined every time through the loop. And the whole point of best total is to keep its value for all three loops and to be the greatest of the three loops. So the scope of this variable can't be in here. And it can't be in our function either. But the current total, or this total, it is only used within the context of one roll of the dice. So it should be in here. Now it can't be in this for loop because, again, we are trying to accumulate that total. We need that total to survive all 5 loops of our for loop. So it has to be accessible from outside of our for loop, especially because we need to use it later when our for loop is done. So it has to be scoped at least outside this for loop, but it does not have to be scoped outside the function. So we put it as far in as it can go, basically. And that's, I think, true of almost anything. If you can keep a variable to a smaller scope and it won't affect your program, you probably should. If you don't, it's still going to be okay, and you can probably make an argument sometimes for like leaving things alone, not messing with your program if you need it, but it's just riskier in the long term because it means that more, whatever you change in the future, whatever you add in the future has more of an opportunity to interfere with it. The more its scope is like closer to global. Does that make sense? Let's do a couple exercises about scope, but yeah, basically, if you can afford the time to, always try to put your variables inside the innermost scope that you can. Okay, I pasted yeah. That's the refactored. Okay. I'm going to make a new file in module 4, Control click, new file, and I'm going to say scratch JS. I like naming a file scratch because it's just where you put code that I'm running during class. And then I'm going to open the module 4 in a terminal. Now I could do Control click on module 4, open an integrated terminal, but I'm going to do it the real way this time. I'm in the W6 weekend folder, and I need to go one folder out. So from here out to here. And I can jump up one folder level by doing the command cd dot dot. Dot dot means go up one folder. This is change directory up to the parent folder. And now my prompt says module 4. Of course, you can also do control click on module 4, open an integrated terminal. And all of that is only if your file is in the module 4 folder, which my Scratch file is. Now I can run node Scratch and nothing happens because my file is empty. Yeah, today is pretty
So
rough.
Gus, I have a question.
Yeah.
File's empty, nothing's supposed to happen. What if something did happen? Is that ever possible, and what would cause that? Or shut up and go home and don't ask a stupid question.
Well, that's a good question. Any question you're wondering, other people in the class could be wondering the same thing. I bet at least one other person is wondering, could an empty file be run anything, or it might be possible to have like weird special characters that you can't see in your editor, maybe, but I don't think that is very likely, number one. Number two, Node doesn't really have any kind of like default. So when you run Node by itself, it doesn't, you can put expressions in here, like I said, and you don't have to console.log anything. It will always echo back the value of the last expression that you put into this thing. I'm going to do Control C twice. But when you're running a script file itself, the only way to get an output is that console.log. So there's really nothing that an empty line could do, because even if this somehow evaluated to an expression, even if there's like a number here, it's still not going to print anything. And I'm pretty sure the JavaScript interpreter would just collapse everything that is not there. There's actually no characters in here for it to interpret. So it would just basically say, okay, I'm supposed to run this file and I'm done. And there's nothing to do. There's nothing for the JavaScript interpreter to do, because by executing the file, it's starting to look for characters. It's actually looking for, something like a
something,
var
yeah,
or a let, and it takes action based on largely what is separated by space. So usually, every meaningful token, it's called, in this language is separated by a space or another special character.
Yep.
So
spaces mean something in this context.
When you're next to a let, the space means something. If I said let G, now it means something else. You notice how it changed color, and it's no longer a keyword, it's a name. So the space tells the JavaScript program that, yes, this is a keyword. And then I say my thing equals, the space here is not needed. JavaScript will understand that the equals operator is the equals character. And if you have a whole sequence of these letters, that's got to be a name. Sure, you could put a number in the middle of it. That's okay too. You can't start it with the number. JavaScript doesn't like that. But this is all valid as a name. It knows, though, as soon as it gets to a non-alphanumeric, it's not an underscore, that's okay. Dash is not okay. But underscore, any of these are like, it's fine. It's like, okay, this is a name, boom, equals. It doesn't need a space there because it knows, well, equals is an operator. It can't ever be anything in this context other than an operator. So yeah, you don't need a space. It's normally convention to put a space just so that when you see it with your eyes,
right,
visually separated and easier to understand.
Also, one other question. Console log, you always end a JavaScript program with that?
No. This is
Oh.
just for demonstration
Okay.
purposes. And in fact,
So-
when we get into building our React applications, our web applications, you pretty much want to remove all of the console logs from that and not put them in once your program is a final program. Now, for debugging, you put console.log everywhere. You can say, I want to log the value of this thing that I expect to be present. You know, I want to load something from a web server and do something with it, but it's not working. So I'm going to add a console.log in the middle of that, and it will print to my browser console, and I will see, oh, well, the value isn't what I expected. But that's really the only time you do console.log in the context of a web application, because users can't see the console in a web application. They see the page. They don't even look at that console unless
That's
they
their
know
user
to go to the
interface.
developer,
Yeah.
unless they're a developer. Yeah. So console.log, once we get to React applications, you're going to be using it, but you're pretty much never going to care or want to ship your code, your final code that contains any console.logs, because they're only useful to programmers once you're in the website. Yeah.
So how do you run a JavaScript program?
Well,
within context like a web page, right?
it's more of a question of what side effects does the program have. So this is kind of getting into a bit of an academic topic, but
We can hold off. I just
yeah. Well, so basically, like here's what I'll say. A program that has no side effects. So a computer program that causes the CPU to do some addition and blah, 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 but it has no side effects to the outside world is indistinguishable from a program that does nothing. And some environments, some like running environments, maybe even the browser environments, they would in fact optimize a program that has no side effects to nothing, to literally run nothing. It would say all of this code is useless. It doesn't cause any effects other than having the CPU add stuff. We're just going to skip it all. So when you say do something, or when you say, how do you get your program to run? It's probably better to phrase it like, how do you get your program to have an effect, to do something? Because whether or not it runs is a bit of an academic question sometimes, okay? Does that, like, it's a little out there, but the program's usefulness, what it's actually used for, can only be defined through its side effects. Console.log is a side effect because it causes something to go to the console. Now in browsers, manipulating the page is also a side effect. So when we get into React, you're not logging things to the console so much as you're changing the layout of the page, and you're causing, like we caused the Lady Gaga head to go around in a circle. That's a side effect. That is the program saying that, hey, I want the web page to change. And then way over here, there's another program, kind of basically another whole program managing the web page. And it's saying, well, I'm going to cause the layout of this web page to change. And then inside your browser, way down in the guts of your browser, there's something that's saying, well, here's my web page. I'm going to take all those pixel values, all the colors that are in each pixel of the entire page, and I'm going to send them over to the screen of the computer, the graphics card of the computer. And then the graphics card of the computer takes all those pixel numbers and it turns it eventually into signals that go to your screen, your actual screen, and electrical stuff. So it's all that side effect chain of effects that cause the screen to change, which is really what you want our programs to be doing. So they're all running. You could consider, this empty file is running just like any other file. It might, do something that has no side effects, but if it does, there's no way to tell. There's no way to tell whether it does or not. So console.log is a side effect. Changing the browser page is a side effect. And any program you write that has a purpose must have at least some side effects. So it's a little bit of an academic thing, but that's a very, that is something people talk about a lot. Like, you know, is it really a computer? It's like if a tree falls in the forest, does it really make any noise? You know, it's the same kind of idea. Like, is it really computing if it produces no effect? Yeah. Okay. Okay, back to scope stuff. But see, that was not a dumb question because it is a very interesting topic, actually. And I think that's usually the case. Like, it's there are reasons to be confused by things like console.log. Very good reasons, I guess, is what I'm getting at. Yeah. Okay, here's our example. And we can do node. Oh, come on. Yeah. Node scratch.js. We get an error. And this is why. We've defined a global variable outside the scope of our function here. Remember, defined means that we've used a let or a const keyword to actually start that variable up, to actually initialize it, to say, this is a name that now should exist. In here, we're referring to this variable that's outside the scope of our function. And we can see out of our function and manipulate that global variable. Inside of our function, we are also declaring another local variable. And then from our function, we are returning that local variable, which is in here, and +5. So adding, in this case, it'll be 2 + 5. We're going to be returning the value 7. So if we console.log the result of our function, we're going to log what it returns. We're going to log 7. Then we could log the global variable, and that's now going to be 2 because we defined it up here, but our function reached out of its scope into the global scope and actually assigned a new value to it. And that now it's the same variable. We've assigned this value to this variable while we were inside of our function. So this will print 2. This one is where it's erroring. This one doesn't work because we defined local variable inside our function, but once we're done running our function, we run it here and we're outside of our function, this is no longer visible. We can't find anything called local var. And notice how it says, local var is not defined. And that's because it was only defined in a scope that we can't see into. We are outside the scope where it was defined. So if we comment this out, we won't get our error anymore. But you'll see that first we get our 7, which is what we returned, but we still don't have access to the local var, so that this won't work. And when we log our global var, we're going to see 2 because we have updated it. Now we could also do global var +1. So global var equals global var +1, and that will give us the same result, 7 and 2. But if we run do things a whole bunch more times, oops, each time we're going to be altering global var. And now when we log it, it's going to be like 5 or something. 6. And that's because every time we run this do things, it's going to reach out of its own scope into this containing scope and alter this variable, which will persist after the function is over. And then the next time it has already been updated. So we're adding 1 to it each time and assigning all the way outside of our thing. So each time you run the function, you could effectively get a different result. If we forget about the local var for a bit, or no, we could say local var plus global var.
Hey, Gus.
Yes.
Carolyn wants to know where this program had the same variable both inside the scope and outside the scope, but assigns a different value to each. Can or should this actually be used as a coding practice?
The same variable inside and outside? Do you mean global var here and global var here? Do you mean this program or the last one? Because
no, she's saying yes to your first question. What you were just highlighted there, the two.
Okay. So there's only one global var variable defined in this whole program. We are accessing it from inside this function scope, but there's only one global var variable, and it only has one scope, and that scope is the entire file, the scope of the file, or the global scope. So
Okay.
in general, I would say you you want to try not to have your function alter a variable or even arguably interact with a variable that is in the global scope if it doesn't have to.
Right.
There's no reason to do this other than to demonstrate that we are reaching out of the scope
Okay.
and altering something outside of it. This is not an example of something you want to do.
Okay, I was just wondering about that because the things you were talking about, the side effects of
Kind of an example. This, especially
okay.
right here, is an example of something you probably want to prefer not to do. Yeah.
Okay, thank you. Appreciate that.
And
you're trying to lead us astray.
Here's another thing why. We'll get rid of these console.log, but watch this. The first time we're going to log the return value of do things, and we'll actually log it over and over and do nothing else. The first time we run this, we're going to have one, we're going to add one to that and then assign it out here. We're going to have our local var and we're going to add them together. So we're going to see 4 the first time we run this. The next time we're going to see 5, the next time we're going to see 6, because each time we run the function, we are altering something global, which is then looked at inside of our function and used for its return value. So every time you, no, I didn't save it. Every time you run the function, it's going to return a different result. And that's generally a bad sign, because we're running the function with the same parameters. There's no, but depending on when you run it, the result might be different. And it's related to the fact that we have our function interacting with this global scope. So if this is exactly what you want your function to do, if you want your function to if you want the behavior of your function to depend on something right outside of it, if you really want that, then maybe you do want to use this pattern. But in general, and I would say even if you think this is the right way to do it, there might be a better way that allows you to make your function pure, meaning it doesn't rely on anything outside of it and it doesn't have any side effects, which is going to be in general a safer way to proceed programming. So even if you think you do want to do something like this, there might be a better way to think about it. I would definitely reach out with questions like this. If you ever want to post in the, in the chat or whatever, hey, I think I want to put, I want to have my function interact with a variable outside of it, and ask the question, because you might be in a situation where it genuinely is the best way to go about it. But I would say that's rarer than you might think. Yeah. So generally prefer not to do stuff like this. It would be better to pass to pass stuff in. And then, you could pass in global var as this other thing each time. From out here, yeah, global var is in the same scope as this. inside the function, as long as you don't change other thing, then it's, it's good to be, actually you can change because it's just a number. But generally, this kind of pattern is more what you'd want, because in this case, the function now has predictable behavior. Even though your global var is changing, and it could change in the middle of this, your function, given the same argument, will always produce the same result. So the 3 times you call it global var is 2, or sorry, the 3 times you call it here global var is 1, it always produces the 3. And then you can change global var, sure, but these 2 times, you call it with a different value, then it produces a different value. That's much more predictable. Even though it's 2 different results from your function, it's much more predictable why these ones were one value and these ones were another one. Now, one other thing to watch out for. Let's say our global var is an object. So remember we did objects like this. And it has a key called my key. And the key has a value of 5. Whoops. You don't need the comma, but I'll put the comma anyway. Let's see, my object. We'll call it my object. And inside here, we'll define our local var again. And we'll say my object dot my key equals 10. And then we'll return local var plus my object, my key. So we're going to do things with the global var twice in a row. And we're passing in our global object each time. And it's going to give us 2 different results. Because, no, it's, wait a minute, what? Wait a minute, no. Oh, whoops. Let's see, how do we do this? Const result equals this. Let's change my object, my key, and let's return result. Now we'll get 2 different behaviors. We get 7 and then 12. And that's because changing this really does change this, even though you passed in your object and you're kind of like, you're working with it inside the function entirely, you still altered something that is global, because objects are passed into functions by reference, not by value. This is that whole reference versus value. Objects and arrays, if you do something like this inside a function, it's going to alter the outside world. If you said global var is just a number, and you say my number, I guess, and everywhere instead of my object dot my key, we do my number. And then here I still assign my number equals 10. And we do the same otherwise. This is not going to have any effect. We still get 7 and 7. Our global var never changes. And that's because my number was passed into this function by value. The actual value 5 was bound to a new name, my number, and it's bound by value. The value 5 is bound. So when I set the variable here, when I assign a new variable value to it, that has nothing to do with global var, because global var was just passed, the value of global var was passed in and became my number, not the reference to where it was. When you do this with the object, the thing that's passed into the function The thing that is passed into the function is that reference. So when you do the dot and you assign to what's in the dot, you're looking in the same place as this global var, and it is yeah. This is a little confusing, probably a lot confusing. But this is the essence of the pass by reference and pass by value stuff that we did on Thursday. The thing that's passed into this function is just telling you where to locate this object. And even though you have a new name for that, you've assigned that reference a new name, it still points to the same object in JavaScript's memory. So when you change any of the properties of that object, you are effectively changing the original object. Yeah, so this is a case where not only do you not necessarily want to, what I'm saying is not only do you not want to do stuff like global var dot my key and global var, not only do you not want to look out here to just grab your initial variable names, even if you pass them in as something else, my thing, even if you pass an object in as something else, this is still risky because what you've passed in is just the reference to that object. I bet everybody is stumped by that one. And that will take a little while. Basically, I'm sorry to say this, but basically, this kind of thing is not really going to click for you until you have a couple of baffling bugs where you probably spend an hour or two wondering why your program is broken, and it turns out it was this. So I don't know if there's any easier way to explain it so that you can avoid making those mistakes, but as they say, a master of a craft is just somebody who has already made all the mistakes. So yeah, I don't know if there's any way to explain this that's going to allow you to avoid getting trapped by the thing I'm talking about. So don't worry about it too much. And when you get stumped with some baffling changes to your objects that appear to be, you don't expect your objects to change, and they do because you called a function, let someone know and we'll help you with it. And you'll get it eventually. This is stuff I still forget. This is stuff my colleagues still forget. You forget that you are working with an object, and you forget that, you can't do stuff like this because that is risky. That alters the rest of your program. This is stuff that like veterans do still. And it's just, it's all because of the relationship between scope and the fact that objects are reference types, not value types. And the fact that because they're reference types, they're passed into functions by reference, not by value. That's what all this, that's the academic way to describe all of this crazy nonsense. Okay. Let's take a break. This is I think enough of this for now. Let's see. Yeah, takeaway, local variables are block scoped or function scoped. Use const for block scoped immutable variables. Use let for block scoped mutable variables. Only use var if you really need a function scoped variable. I don't know why you would necessarily need a function scope variable. So pretty much just don't even use var. Just use these two and assume that they are scoped to the if statement, the while loop, the for loop, the function, or whatever it is that contains them. This is just a demonstration of the difference between var, old school var, and block var. Or sorry, block, let. It should be like let. Oops. So this, in this case, my editor's already told me that, hey, blocklet this is a brand new declared variable. It has nothing to do with this one, because you're in an if statement, and let is scoped to your if statement. So you declare it in here, it doesn't exist out here. Var is different. You're interacting with the same thing here, here, and here. So one will change it because I've modified it inside the if statement, but the let will not. The let is scoped to blocks, not just functions. If statements, while loops, everything. And that's all that is. Okay, let's meet back at 7:30, and we have some stuff with arrays and objects. And yeah, I don't know if we're going to get to the example very much today, but that's okay. Yeah, we'll do that. And I think one of the things I want to show is let's do a couple of free code camp exercises, just one or two, just because I really, really want to endorse that. You should be doing these exercises when you're stumped by a problem, or when everything is so confusing. I would just pull back a little bit, let off the gas a little bit, do some exercises, because they're definitely going to help you. We'll do that after the break. And then I want to show you this other thing that has a really cool little course on JavaScript arrays in particular, which is a pretty cool way to learn arrays that I like. So we'll share that, and we'll do some of that for the rest of the day. So see you at 7:30. Yes, 7:30. Be right back. Oh, I can play some jazz music.
Hey, Gus.
Hey.
After class tonight, when I was helping Carolyn, and I don't know if yours does it or not. I know my actual, if I minimize a window, you can see that I minimized it, next to the applications folder, between that and the trash can.
Yeah.
Hers does not do that. So I don't know if that's a setting or not.
If that's Carolyn's Mac, you click the orange thing, and it just disappears.
Yeah, it just goes to the application. It doesn't put it in between the application folder and the trash can like it normally would.
Okay. I never clicked that button, by the way. I'm like, really? I don't like having stuff like that. But yeah.
The only reason I'm saying that is because I think she had a couple of windows of VS Code open, but she couldn't see them because when you minimize them, it doesn't. It just goes to the application itself down in the whatever the bar there.
Yeah,
whatever
that's odd.
Yeah.
I don't know why.
I don't either.
Mac minimize goes to application icon. Here we go.
Because I think she had two windows of GitHub Desktop open, which was part of her problem, but we couldn't see that because if it was minimized, it didn't show that.
I think probably it looks like this checkbox here. So if you go to System Preferences, and then Dock, where's Dock?
Okay.
Dock and menu bar.
Yep.
Minimize windows into application icon. That looks like it.
Okay. So we'll have to see, or I can do it after class and just see if that's checked on hers or not.
Yeah.
So that
it probably is checked if it's doing exactly this. Yeah.
Yeah. So we'll get that unchecked because I think she had two windows of GitHub Desktop open. So when she pulled code, it had an issue and it was like, it was freaking out or doing whatever it was. So I just closed it out. And once I closed it out and removed whatever she had there, she was fine.
Cool. Yeah. I do that every, once in a while. I do like a great purge of look at how many VS Code windows I
Yeah.
have. It's usually a lot more than this. It's like,
Yeah.
yeah. And they have random notes in them. I'm pretty messy with some of my organization too. But it's a really, it affects it's definitely a handicap for everybody. And especially if you're like trying to get used to some of this, it's a lot to deal with. Yeah.
Yeah. And I actually, Jesse showed us when we were in the cohort 1 tab, and I hadn't used it in a while, but the other day I'm like, oh my, I have like 8 windows open with like 12 tabs on each window. I'm like, I need to minimize these and get them. So I just pushed them back into 1 tab, but I locked them so I would know what I wanted. I was like, this is crazy. I can't.
Yeah. Yeah.
So, all right, I am going to grab a drink and I'll be right back.
Okay. Yeah, me too. Could make some coffee, but I don't know. I'll run to the bathroom. I'll be right back. All right. Are we how are we looking? A minute or two more? Are we ready? Let's see. I think we should get back to it. All right. So now I want to show a couple of extra things, not extra, but like some more details about arrays and objects. That whole reference, it's important that they're by reference. You got to watch out for that thing. But there's a lot more to arrays and to objects that are useful tools that you can use. And for some of this, I mean, partly because like I didn't have the right slides for this, but also to kind of get used to looking up some documentation and trying to kind of like make use of the resources that are out there. How do you click a link? Oh, so you click on this and then you click this, I guess. Anyway, this URL has a bunch of information from Mozilla about arrays. Now, a lot of this is very confusing, and you probably won't understand this right now. A lot of this is hard for me to understand, but it has to do, it says who's prototype. We haven't talked about that yet. We've talked about objects, though. We've talked about methods. Methods are properties of an object that are basically functions, like functions that are contained with an object. How's that? This, to get to something up this page, and in general, if you want to get to some information that might help you about any JavaScript concept at all, so this will apply, as we get further, and you will be able to make use of these resources actually better as you start to understand more of the concepts that they're talking about, like object prototypes. We haven't seen that yet. But you can type in basically the word MDN or the letters MDN, and then whatever you're wondering about. So like array. And the first result almost always is going to be the MDN page on whatever the thing you're looking at. So MDN object, we'll give you this MDN variable. We'll give you something about variable or const. Const, we'll give you a page about const. And it will be a very thorough bit of documentation which goes into a lot of detail, not all of which you might understand right now, but it's a good reference, and this will be kind of like a long-term, this is going to be a resource you're probably going to be checking a lot, because it basically is the easiest way to jump to sort of standard JavaScript documentation about whatever. And if we go back to the array page, so we'll do MDN array. Now this top stuff, it's very sort of general description of what arrays are. A global object used in the construction of arrays, which are high-level list-like objects. So construction, kind of weird. Prototypes, kind of weird. Blah, 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 blah. Now, there is useful stuff on this page right away. So don't worry so much if you don't understand the exact meaning of all of this right now. There's still a very useful list of common operations. So if you're wondering, how do I make a new array? One of the first thing is create an array, and it gives you a code example. Now their code examples don't have semicolons, and if you don't like semicolons, you can probably ditch them, but I like them, so all my examples have semicolons at the end of the line. Other than that, this is just like any other class example. You want to see an example of creating an array, it will, that's making a new array and then logging it. Access an array item using the index position. Well, this is if you don't remember, the square brackets are used to pull an object, to pull one of the items in an array out of the array. We use this with our random die index here to grab the corresponding dice symbol. And you can put an expression inside the square brackets too, like it's saying. And here is basically the examples they give you are the first item will have index 0. This is a technique to grab the last item in an array. An array itself has another property, because arrays are kind of also like objects, but it has a dot length. So if you wanted the last item in this fruits array, you can always get the last item by getting the item at the index, which is its length minus 1, because it starts at index 0, index 1, and its length will be 2. So this will be 2 minus 1. And so you'll get index 1, which is banana, because it's index 0, index 1. The only time this won't work is if you have an empty array. Its length will be 0, and you'll try to get -1, which will be undefined, I think. Now here's some interesting other things. Arrays have methods. We've already seen map. Map is down here somewhere. No? Well, it's not one of the examples. Well, you can do something similar to map, but it's just looping over an array and running a function for every item in that array. So unlike map, this doesn't transform it into a new array, but this is a way to, instead of writing a the equivalent would be something like, oops. The equivalent would be something like for let I equals 0, I is less than array.length. Whoops. We do const my array.
You have a typo in length, but does it matter if you'd use array capitalized or lowercase? Because I noticed that you changed it to lowercase.
Capitalize matters because that's a special, that is a special built-in JavaScript object. Notice how it's green. This thing is part of JavaScript, and you can see that it has all these properties. The most important, which is prototype, which we haven't gotten into yet, but if you look at prototype, this has all the methods that are on any array. It's the same as like doing 1, 2, like that. A literal array will have the same things as array, capital A array dot prototype. And it's just because that capital A array is a special JavaScript object, which is used basically to build other arrays. But we'll get into prototypes probably tomorrow, I think. Yeah, but really the variable is my array. I have to declare it somewhere, dot length. So this for loop starts at 0 and goes until I is just below my array dot length, and it runs whatever's in here one time. Another way you could do this, as pointed out here for looping over the array, you could do my array dot for each, and then you get value index. This would be the same as I, and the whole array, which is a little odd, but it's similar to a map. But you know, if you do console.log my array I, this would be the same as doing console.log value, which you could also do that because you're given these other two optionally. But if you just wanted to do something with each value in the array, you could leave those two off. You could say this. And this will now have the same effect as this. It's a different way to loop over an array. It's a little more advanced because this uses a function. Remember this function expression here, function passed to another function. This function takes an argument, and its argument is another function. And then inside that function, you are describing what to do with each item in the array. It's the same as like for map, but map would be used, rather than just do anything for the array, map would be used to change everything in an array into something else. Or not console.log, you would want to return value plus, I don't know, pi. So you could transform with the map, and I'm just rambling now, but you could transform an array of fruits into an array of pies by taking fruits and mapping that and giving this the function expression return. This is another very, very useful method that's on every array. And this set of examples is some nice, common things, but it doesn't include map, which is weird. I don't agree with that. To find all of that kind of stuff, you have to scroll way down, 0 index, accessing array elements, and so forth. Length between length and numerical properties. Updates to an array's length property. Basically, they're saying the length, the fruits.length is always the length of fruits. Creating. So here, once you get down to this section, and specifically for an array or an object, instance methods. This is the useful stuff. This has map. This has keys, join, index, includes, for each. We just did for each. Find, and it'll describe what each thing you can do with an array. Now, this is good as a reference for anything in JavaScript, but it is very, very hard to kind of understand because it's so technical and it involves so much. It's all array.prototype.slice. You kind of have to know that I can now do fruits.slice. That's sort of what that means. I can slice on any array. But the way it's described here is a little confusing. Generally, though, if you find this section for array or object, this has some very nice ways, very, very thorough explanations of how they work. Reduce is a huge one. We could spend a whole class on reduce. This is a very cool technique. This allows you to combine all the elements in an array in any way you want. You could add them together. You could make an API call for each one and take the results and do something with it. You could do all kinds of stuff. So that's a crazy one. And each of these methods is a link to a very long page about how it behaves. It tells you what it returns and so forth. So this is going to be not as useful right away, but long term in your, as you're kind of like getting more comfortable with this, when you're at work working with this stuff, this kind of reference is going to become more useful as you get more used to using the parts of it, the parts of JavaScript. For now, I think a much nicer way to learn arrays, rather than just hit the reference book and try to read through it, a much nicer way is either something like Free Code Camp, or this has a very interesting course that's all about JavaScript arrays, and it's pretty cool. I would suggest maybe trying this out. So here's this, and basically it starts like this. I think you have to scroll all the way down to the bottom. JavaScript arrays. And this goes through some really cool exercises. You can do it all with the keyboard here, and you can hit enter. It works like the node command. So, well, I guess you click, and then you can use just the keyboard and enter like you're typing at the node console, but it will explain things. It explains itself first. You hit enter, it'll do an explanation. Read all of this and see if you like this. And then it prompts you to enter something. So enter the result of 2 + 2. You could say 3, but it doesn't like that. You have to say 4. And then you can just keep hitting enter, and it all works from the keyboard. So 1 + 1 inside an array block inside a literal array is 2. They just gave you the answer right there. And if you get stuck, obviously reach out. You might find this nice for learning arrays. The other one, obviously, is the Free Code Camp exercises. Those are they're not targeted all around like everything about arrays. They are just general JavaScript topics. But like we should pin, let's see, do we have pinned items? Let's see. We should pin that Free Code Camp right to this channel because, yeah, I'm gonna pin to channel. So this here is always a good way to practice, and practicing is always worth your time, especially right now, because a lot of times, you're going to hit limits of like how much new strange concepts and confusing principles and concepts and everything that you can absorb at any one time. And you need to stick with it every day, obviously, or as many days as you can. But if you're just not feeling like trying to understand something directly and immediately and completely, it's really probably sometimes better to just say, I'm going to do some exercises, not worry about, the grand concepts. And if I get stuck, I'll reach out for help. And you kind of will absorb a lot of the same concepts gradually, just by osmosis. And that's, always a good thing. There are some of these concepts, like maybe some of that scoping stuff we talked about, that are just going to be very difficult to understand unless you get some practice actually doing them. And that's where this comes in. That's where working on your capstone comes in. That's where really actually doing, solving problems and writing the code yourself is really necessary, to get to that level of understanding, probably for all of you. I don't know if some of you might be like, you can just get it, but you're not. You are exceptionally gifted if you can just understand all that I just explained about scope and pass by reference and pass by value, and really understand all of that without really practicing it at all. You pretty much, yeah. So yeah, so the one problem I have with the free code camp, and kind of why I like that other link for the arrays, is because it's all kind of themed around arrays. It has a very targeted kind of like focus. My biggest problem with free code camp is it just seems to be just this massive list of stuff, and you don't know which one do I do. Basically, you should start at the top and do all of them, even though they're going to be out of order with something. But there's really no better recommendation, because honestly, you probably want to go sequentially, but it bounces around a little bit. Like there's some of them are pretty easy. Let's do a couple, and I'll just show you. The flow, it goes pretty quick if you're getting used to this. Once you get used to this. So the first lesson is all about comments. And it says create one of each type of comment. We already saw this one. I didn't tell you at all about this kind of comment. Here's another way you can comment some code. Now, an easy way to solve, it says create one of each type of comment. I don't recommend this. You should probably type in everything you can, but I could copy this right over here, and copy this right over here. And in this case, I think that's all we need to do. But I'll type them out. I'll do //one comment /* other comment //. Okay, one of each type of comment. And now once you're done and you think you want to proceed, you can say run the tests. You scroll down on this side, on the left side, click run the tests. And we did it. So you might want to sign in. You might want to make an account for this. Go ahead and do that. I'm going to do that right now. Let's see, Google account. I've signed into your account. Okay, well now, no thanks. Their site is broken. All right, well, I'm going to give up on that and go back to Slack and click the link again, because I don't know what's going on with, clearly they're not the best at JavaScript either. Okay, back to comment. Wait a minute. Oh no, I have to say yes, I want spam? I don't want spam. You've got to be kidding me. Their site doesn't let you continue unless you agree to get spam. That's a bummer. Okay. It's this one, but I'll just go back to the link in Slack. We'll go to comment. Okay. And it's saved. It should save your progress if you use the same browser. Anything you change should get saved, which is good. And I believe you can do Command Enter instead of clicking on the other thing. Once you get in the flow of this, you can just type and do Command Enter to check your answer. So submit and go to next challenge. Declare JavaScript variables. Well, we've already done this. Some of this is pretty easy. They say use var, which you shouldn't really use unless you need it to be function scoped. We're way more advanced than this, but I guess we just have to go with it. So I'll say var my name equals blah. Oh, it says you should declare my name with the var keyword ending with the semicolon. So these people say definitely use a semicolon. They don't agree with the MDN people. Maybe you're not supposed to assign anything to it. Okay. I think it's supposed to look like this, and you're not supposed to assign anything to it. Hooray. Storing values with the assignment.
Yeah, the exercises are pretty literal. You don't really do much programming or creativity. And sometimes it's confusing because you're not quite sure what they want you to do because you think you should be doing more. But it's very much, it's over here, do it over here.
Yeah, and I think there's good and bad to that. It's not going to necessarily, you're not going to necessarily learn what everything is for, the meaning of everything. But on the other hand, you're not going to get as stuck as you can, like trying to solve a homework problem or trying to solve, one of the puzzles that, trying to understand the bigger, meatier examples we're doing in class. It's going to be much more just little bits, little bite-sized pieces. And it's a much nicer way to sort of decompress a little. If you're just overwhelmed by this will just help you absorb, try little pieces. And it has all the pieces. It has arrays, an array map, and all that kind of stuff. But it's all like one little piece at a time. And there isn't like these grand puzzles. They do have a very interesting puzzle, or actually a set of them to complete the course. Oh, it should have a value of 7. So down here, it will give you feedback like, here's what you did wrong, basically. A should have a value of 7. Yeah, it does not. Okay, next challenge. And assign the value. Okay. Only change code below this line. Okay. So I assume assign the contents of A to variable B. This, you can read all of this if you'd like the background on it. I'm comfortable enough with JavaScript. I can probably get through most of these just by seeing what it's telling me to do. So let's see, B equals A. Hooray. Define A with var and initialize to the value of 9. Var A equals 9. Yay. Initialize 3 variables, A, B, and C. Wait, only change code here. With 5, 10, and IMA. Okay. I wonder if it's okay with single quotes. Whoops, I need an equal. Yay. Anyway, this is basically just a much different kind of way to approach the material. It's a much more kind of, hopefully less stressful, less intense. It's not necessarily going to, it's not, there isn't going to be a lesson here that will teach you how to write your capstone. But all of the time you put into practicing, it will train your fingers. It will train your eyes to see the different parts of the program. It is good training. This stuff will help make everything else easier. As you get more comfortable about just recognizing the parts of your program, typing things, noticing typos, all that kind of stuff. And it's going to explain each concept in case, you're never going to be stuck like, well, if you get stuck, let someone know. But it's going to be a lot harder to get stuck because whatever they're asking you to do will be explained directly right here. There's going to be no big puzzles or surprises, really, with this material. Yeah. And the free code camp has, yep, that is true about the free code camp exercises. They do not require you to type in the exact answer. There is no exact answer, like we've talked about a lot. There are better and worse answers. The way that they check is if you scroll all the way to the bottom of here, you see these little beakers. All that they care about is your code has to satisfy all of these tests. So as long as this variable is defined with the value of 10, and this variable is defined with this value, a string, and all of these, as long as all of these pass, then you pass the lesson. That's how it works. So I don't know what this one's about. It's probably just, teaching you to use the standard case, camel case. Yeah, and then at the very end of this, I actually tried this puzzle. Where is it? At the very end, there's like some really, really cool puzzles. So if you think you got the JavaScript, if you are like, I think I can program, I could figure stuff out. I did the first one. It's not easy. And these, I haven't even really tried the other ones. I want to try all these, I guess, but try this palindrome checker if you think you've got all, if you want a real head scratcher. Oh no, that's the answer. No. Oh no, don't go on YouTube and copy my answer, okay? Like, it's an answer and it works very well. But if you think like you've figured out like all the stuff so far, this one you might need regular expressions, which we haven't covered, but everything else you need we've already learned. If statements, for, while loop, that kind of thing. But don't expect to be able to solve this palindrome checker at the bottom all right away, or any of these puzzles at the bottom right away. They are basically like the final exam for JavaScript. So we've got a long way to go. Anyway, so that's just like my pitch to do the free code camp exercises when you can. I really do like this other site that I posted. For the arrays practice, and once we learn regular expressions, I bet this one's pretty good too. But it's eventually going to say, sign up and pay us some subscription for this. So, it's a cool thing to get some basic. It's not free. So that's the trade-off there. Okay, Susan, do you want to, did you get unstuck or are you still stuck? Well, okay. Yeah, I don't.
Now I'm sorry, I muted this through my headphones.
Oh yeah.
Thank you, Ariel. It was just it was quotes within the quotes and then blocking them out so you can actually show the quotes.
Oh,
it was it was so nitpicky, and I was like just getting stuck, and I finally got it, but it was really irritating.
Oh yeah. Well, I think the general rule for something like this, and really always, then this is what I tell colleagues, and this is what, I think is a really good guideline. If you get stuck on anything, if you get stuck on your capstone, if you get stuck at Free Code Camp, if you get stuck with some of the homework, try to get unstuck for at least 15 minutes before asking for help. Just try, even if it's hopeless, even if you're just like, I have no idea what I'm doing, just try whatever you can do for 15 minutes, or sit there and stare at it for 15 minutes. And then just consider, like, asking for help is possibly the right thing to do at that point. You don't feel bad about asking for help ever, for Free Code Camp, for anything. If you've spent at least 15 minutes sitting there thinking about it, that's plenty of time to be stuck. You shouldn't necessarily have to be stuck longer than that. Now, of course, if you're stubborn, if you're like, I can solve this, I don't want help, I'm going to keep trying, you're welcome to do that. But, that's what I tell people is be stuck for 15 minutes. But after that, really, if you're sick of being stuck, ask someone for help. That's fine. And yeah, I think that goes for all the instructors. And, yeah, if we're able to respond on Slack, we'll definitely help you out. And if you post it in one of the channels, just the general students channel, there's so many people who are like instructors and everything. Someone will probably see it very quickly and give you some help too. So, it's yeah. If not, send me a direct message and say, hey, I need help, then that's fine. Okay, let's see. We have 25 minutes left. I want to say the readings for tonight, readings are always optional because they're going to take you longer than 15 minutes. They're kind of reviewing stuff that we've already seen. This is like some basics about objects and arrays, but it's a cool scenario. And if you wanted to do, another approach to objects, properties, methods, and some of the other things we've already seen, mutability, this is where, you can, they're talking about value and reference types in just a different way. And then they go through this whole little story where there's like a bunch of random math. There's this thing, which I'm like, oh, come on. You're trying to, I don't know what that's a weird math symbol. But, if you want to go along with this, and just follow all the exercises, and try to understand the math if you want. This is a nice approach to, some of the same things. So they're talking about material we've done, maybe some things we haven't talked about. This is a thing we haven't talked about, but it's good reading to do as an alternative to, Free Code Camp if you want to, just spend some time getting more familiar with the material. This is definitely going to be more thinking involved, or more like difficult kind of concepts than Free Code Camp. But the reading is always kind of nice. And if you have questions about any of this, please reach out to the homework tonight. And then we'll look a couple more things. But the homework for tonight is not code at all. It is to basically download a file, a zip file, extract it on your desk or onto your desktop or somewhere on your computer, do some basic kind of file manipulation, change some of the files, and put a new JS file. Just follow these steps if you can. If you get stuck, it's fine to reach out for help, of course, like all the time. And the submission is just zip it back up once you've done all the steps and upload it. And this is just kind of a touch point to, see, basically, if you might find this very easy, if you're comfortable moving files around and everything, just try to do it, please. If you have trouble with this, like let someone know, and then we'll know where you got stuck. We'll know what we need to kind of emphasize more and learn more with the files thing, because we've been skipping a lot of this file stuff by doing our, open in VS Code process, which by doing this button and everything, we've been kind of trying to skip having to do a lot of the file management in class, but we really do need to make sure that, everybody can manage files on their system, to some extent, be able to download and upload and go to, eventually you're going to be checking in your code to your capstone if you aren't already. And you're going to have to be comfortable with all those things too. So that's what the homework for tonight is. It's, sounds good, Ariel. Let me know. And yeah, that goes for anybody. If you want some help, I'll be around. Here is Karen sent this to me. I've never seen this one. Tutorial for beginners.
There's a lot of practice on there for just practice problems. If you go under challenges.
Okay. Well, gee, that takes a while. Very fast. So challenges. Oh.
And you can pick if you want easy or hard or medium or whatever.
Nice. Let's try expert. Each person in Italy has a unique identifying code by the National Tax Office, the fiscal code. Given an object containing personal data of a person. What? Generate 3 capital letters from the surname. Okay, this is complicated. So it's turning somebody's information into some code according to some protocol. All right, don't try that one right away. I would try easier, maybe easy. Ooh, bitwise. Okay. Yeah, this looks like fun too. If you want some more puzzles that are not necessarily all incredibly hard, that's probably a good resource too. Okay. Let me do a little bit more, because we don't have time to start. We don't have time to even start our example code. And honestly, I don't know if we're gonna have time this week to really do that example at all, because it's a pretty big, it's a lot of code. Maybe I'll do it for office hours, but that's a really cool example. It's fun. Well, I'll just show it to you. And then if we can vote on if you want to see the breakdown, if you want to see writing it, I did this in the cohort 1. This is, you make the computer perform a card trick. So if we go to W7D1 card trick and do open in integrated terminal, we need to do npm I, which installs this and this, because we have them as dependencies. We need a node package which gives us a deck of cards and lets us do things like shuffle the deck and everything without having to even write how a deck of cards works. And then we need that same prompt sync. Oh no, I should do okay, never mind, whatever. We need these 2 dependencies, so we have to run npm I in here. It'll say added 5 packages or audited 5 packages, but now we're good to go. We can do node card trick after and just run the finished card trick. And what this does is it prints out 3 rows of cards. It says pick 1 card and remember it. So who wants, someone call out one of these cards?
Seven of hearts.
That's King of Spades. Is there a King of Hearts? You mean the
Yes,
King of
no,
Spades.
that's a spade.
Right.
Yeah, there is a King of Hearts, the second to last row middle between the 9 of clubs and the ace of diamonds. Yeah.
Where?
Oh, well, see, I got a different return set than you. Sorry, I'm looking at,
Oh,
I
everybody's
just ran it
cards
on my computer. Sorry.
Everybody's cards are random. So if you run it, you pick your own card, but I'll pick the King of Spades. And it says, which row is your card in? I'll say row 3. And it says, which row is your card in? I'll say still row 3. It's over here. And it'll say, which row is your card in? Now it's in row 1. And King of Spades, now it's in row 2. And it will say, your card is the King of Spades. And it will decide, it will figure out what card you picked just by asking, by shuffling. And the way that it works is pretty interesting. I demonstrate this with a real deck of cards, but this is like a full program. It has interactivity. It has stuff broken up into functions, converting a card to a symbol, all kinds of stuff. So if you want to try to figure out how this works, you might get stuck, but we can also go through this and show the example tomorrow if you'd like to do it as the exercise tomorrow. But we have a lot of material to get through this week too. So yeah, this might be like an office hours thing, but yeah, that's today's example. Oh, and we need to talk about this. Okay, so we have a little time in class left. Let's talk about these 3 dots and do a little bit of explanation of that. So this is called the rest or spread operator. And the official documentation says, spread syntax allows an iterable, such as an array expression or string, to be expanded in places where 0 or more arguments or elements are expected, or an object expression to be expanded in places where 0 or more key value pairs are expected. Okay. So what this means is that, let's just grab this example. What this means is that if you have an array or anything that can be iterated at all in JavaScript, you can use the 3 dots before it to effectively split apart the parts of the array and pass them all as arguments to a function like this. And this is actually the less common use of it. But what this will do is this is the same as calling sum with numbers 0, numbers 1, and numbers 2. So instead of having to you separate things by commas, basically pull each item out of the array and pass it as a separate argument here, you can just say spread the array into the arguments, and it will behave like what I just said. It will pull the first item in the array as the first argument, second item in the array as the second argument, third item as the third, and so on. So you could, if it's only got 2 elements, it's going to be the same as doing this, which is not enough arguments, so your function is going to behave weirdly. But anyway, it's like saying first thing in the array is the first argument. Second thing in the array is the second argument. And if there's a third one, or fourth or fifth or any number, it becomes the argument being passed to the function. So that's when you see these three dots, that's one place where it's used. Here's a couple more. This is when you're calling a function. So we log it here. But so this is just when you're calling a function and you want to turn something like an array into the arguments to that function. The three dots is also used if you want to, for example, make let's say fruits. If you want to take the elements in array and spread them into a new array, for example, that's fruits and veggies. Now we have a new array literal here. We have the square brackets. I can say take everything from fruits and drop it into this array, but then also put broccoli and kale. This, in this context, it's not the same as saying fruits. And we'll console.log this stuff and show what this is. I think honestly, this use of when you're using this three dots for the arguments to the functions, much less common. And I don't know, like in my experience, this is much less common because like the length of your array should match the length of the arguments, and then weird stuff can happen. Functions technically have a mystery thing called arguments, and you can mess with that, but see how that's a special color? This is all weird stuff that's like gonna cause strange bugs, and like I don't really want to emphasize like you should be using this. The much more common use of the three dots is to do this kind of thing. So we want an array that has apple, banana, and then also broccoli and kale. We could say fruits 0, fruits 1, broccoli and kale, but that's not great because we have to know how long fruits is. And if we add another thing, it's not going to be included here. If we want to just say take everything in fruits and include it in this array, we do it like that. And I'll log fruits and veggies. Nope, that's not what I wanted. Control click integrated. If I do node scratch, we can see now that our array has the first two items that we've spread into this new array, and then the two next to that we included. Now you might say, well, wait, I mean, can't you just say fruits and then this one and this one? That's not going to do the same thing, because fruits is an array, and we can nest an array inside of an array. So it's basically going to be similar with that extra set of square brackets still there. It's going to be the same as if you did this. So if we just did fruits and we log that, you notice there's this extra set of square brackets because the first element in the fruits and veggies array is another array. It's our original fruits array. The second element is broccoli. The third element is kale. And there's no fourth element. So if we wanted this behavior, if we wanted our array to be nested in another array, then yeah, we can put just fruits there. But if your intent is to say, well, I want to extend this array with some more stuff, you're going to want to use that 3 dots. And that, again, will take the stuff inside fruits and basically put each one into this array directly. Another way you could do this, yeah, the 3 dots is like always this kind of thing where you're taking something that's array-like, that has like an iteration, that has multiple elements to it, and transforming it or flattening it out or something like that. But yeah, it's used in many different cases. And you can do this actually with objects too. So let's say like, let's say, what if fruits was an object? So this would be curly braces, not square. And our syntax for objects is like favorite. Well, I don't know. What's a good shape of? Let's say it's an inventory. So apple is the key, and banana. So we have, let's say, 10 apples and 40 bananas. And fruits is just our whole inventory in an object. We could do the same thing here and spread the fruits object and then add some more inventory for broccoli and kale. You don't need that comma. I just like ending everything with a comma, just because then you don't have to go back and remember to add it if I added one more thing. But yeah, now we get similar behavior, but it's not an array. We're going to put this key and value and this key and value right alongside this one and this one. So we have apple 10, banana 40, broccoli 50, kale 20. If we did just fruits, it's going to do something totally different. This is going to interpret it as fruits. And we're going to get one key called fruits, and the value will be a nested object, very similar to our array. So just fruits, this is like, it understands this as a shorthand where I should make a key called fruits, and the value should be the value of the variable called fruits. This is a more recent JavaScript thing. Before, in older versions of JavaScript, this would just error. This would say, well, you need a key and a value. You're in an object. But now, it would behave like this, which is a little confusing because it's this value assigned to this variable, which is this value being assigned to this key, which happens to have the same name as this variable, but yeah, only in this case. So yeah, fruits, you get this nested fruits thing, which is not always what you want. If you want to take the properties in fruits, and remember, this could be a method too, by apples, bananas, turn, blah, whatever. I don't know what this is. This could be a function too. It's an object. You can put whatever you want to put in an object in there. It will take fruits. It'll take all the properties, even if they're functions, even if they're whatever, and it will put them in line here. So it's just like saying apple 10, banana 40, and by is, whatever that weird function would be. Whoops. Yeah. So it's like taking the properties and dropping them in place. Different than just the object being nested. one is here. The other one is, these are right alongside the other two. So that's what the 3 dots is mostly used for. And in the card trick case, we're using this to reshuffle our cards, and it's a little complicated what it's doing. I think honestly, this is probably worth spending like a whole office hour on, or as the example. If you're interested in seeing this example tomorrow, we'll spend the whole example on this. If you want, we'll spend, half a class on this. If people are interested in seeing a complete program that does this card trick. But it's a lot. I mean, there's a lot of stuff in here. And let's see, is there anything else we haven't covered yet? This is built into our cards module. We've seen the prompt sync module. We're importing code that we didn't write, that other people wrote. Oh, we have not seen the new. We might see that tomorrow. That's part of objects and their prototype kind of thing. And that stuff is, I don't like that stuff. I avoid using it myself, but it's part of JavaScript and we have to learn. We have to at least see it. So we'll talk about the new. This is because the person who wrote this Dex cards thing, this is how they decided it's going to be used with this new. Yeah, minus equals instead of plus equals. Getting the card to symbol, that's very similar then to die to symbol. That's very similar. Render card rows. Yeah. We've seen join, I think, one time. This is a method on an array. It puts the character in here that you pass it in between each element of the array. And if it's an array of strings, it will take each element, make it a string, put this bit in between them, concatenate all of that together and give you one big string back. But yeah, the spread operator here. Ooh, we haven't seen splice except for Brandy. We did an exercise to look at splice, but splice is just another array method. It's one we should probably actually look at because that one is useful. Anyway, if you want to go through this example in detail, there's nothing here we haven't covered. It just will take some time, and it's a pretty cool result, but it will take like half of class. So I think I'll put it up to a vote tomorrow. Yeah, this is the only thing that we haven't really covered so far, except the new keyword and the object properties, which we will get to tomorrow. But I think we're out of time for today. Any last questions or any questions about the homework? It's not coding today, but it's, yeah, just please do it if you can. Or, let someone know if you can't, please, because we really want to get a sense of like how everybody's doing with file management and things like that too. So thanks. I'll stop my screen share. It's dark now. I need to turn the lights on in here.
Karen, did you still want to try and figure out that toolbar thing, or do you want to meet about that like tomorrow?
That's totally up to you. Gus and I looked at it over break, and we're pretty sure it's just a setting in your.
I mean, it's good for me if it's good for you, or I can wait. Whatever's good for you.
It doesn't make any difference to me.
Carolyn, do you have a system preferences down here like this?
Well, let me go on my Mac here.
Oh man, you're.
I'm watching you on my PC, but I'm working on the Mac.
Right, but so you have all your VS Code and everything on the Mac.
Mm-hmm. Yeah.
Okay.
Yeah.
And GitHub and everything, except for the video, except for Zoom.
No, actually, I have Zoom running and muted and no video and minimized in the background. And that's what I used to screen share with Karen when we did the breakout room.
Oh, okay. But you're on
That's
Zoom.
why you see two of me, but only one of me.
Got it.
Yep. No, it works because, sometimes when you're going through this code, it's just easier to just do it right on the Mac. And I was getting totally lost because I was trying to switch windows and, so this is a new method as of last week. So
Okay.
anyway.
Okay. If it works, it works. Yeah.
Well, we'll see.
So.
All right. So.
If you have system preferences at the bottom.
It kicked me out of the meeting. Okay. So we're not going to do a screen share. We're just going to do this.
If you'd like to try to share your screen, that's fine.
It kicked me out, so
we're done with the normal class.
I got to go back in. All right, hold on.
Any other questions I could answer? Well,
where are you?
Yeah, I gotta go home.
Okay, one moment here.
Good night. Everyone was heading out.
All right. And that I don't need anymore. Bear with me. Go away. All right. Now, where did that file go that I needed? That's not it. Okay. There we go. All right. Hold on. Just gotta get that. It's probably good that it kicked me out after a while. It's the security thing. That's probably a good thing. All right. Here we go. Now I'm back in Zoom on the Mac. I'm gonna mute myself and go my video here. All right. There. Oh. All right. Now we're just hearing me on the Mac, right?
Yep.
Okay. Screen share. Now.
You could probably stop recording, I think.
Oh, yeah. Well,
You wanted me to look?
see you, YouTube. Bye.